Do you want to wake up naturally every morning? Do you want to stay energized throughout the day? The answer is simple. In the morning, expose yourself to bright light. Maintain a consistent sleep schedule. Why does this work? This slide explains it all. Your brain has a body clock called the suprachiasmatic nucleus, the SCN. It's a small neural nucleus located in the hypothalamus. This controls your 24-hour rhythm. Light information travels from the retina through the retinohypothalamic tract to the SCN. This signal resets your endogenous rhythm. The human body clock averages about 24.2 hours, with individual variation, and most people adjust daily. The SCN synchronizes this precisely to 24 hours. Clock genes, clock, BMAL1, period, cryptochrome, are expressed in roughly 24-hour cycles. This genetic network creates the circadian rhythms of physiological functions throughout your body through synchronization of central and peripheral clocks. This is what 2 decades of chronobiology research has revealed. The molecular mechanisms of the circadian clock were recognized with the 2017 Nobel Prize in Physiology or Medicine. It's an established mechanism, and this is achievable. Wake up at the same time every morning. Expose yourself to bright light. Outdoor natural light works too. This sets your body clock into precise motion. Today, I'll show you the scientific evidence. Melatonin, the sleep hormone. From evening into night, your pineal gland begins secreting this. Signals from the SCN control this secretion. Secretion rises in darkness and peaks between 2 and 4 a.m. This brings you sleepiness. Conversely, bright light suppresses melatonin secretion, especially blue light, around 480 nanometers wavelength. This is the same wavelength as a clear blue sky. This light stimulates the intrinsically photosensitive retinal ganglion cells, iPRGCs. These cells send commands to the SCN to stop melatonin secretion. This is the mechanism by which morning light awakens you. Cortisol, the awakening hormone. Secreted from the adrenal cortex, the SCN controls this through the HPA axis. Before waking, secretion begins to increase between 6 and 8 a.m. Generally, it peaks 30 to 45 minutes after waking. This is the phenomenon called the cortisol awakening response. This peak activates your energy metabolism. Glucose utilization is promoted, and your body enters activity mode. However, it varies with stress, sleep deprivation, and measurement conditions. From evening into night, cortisol declines. This prepares your body for sleep. Melatonin and cortisol, these 2 hormones mutually regulate the sleep-wake cycle. Your body temperature fluctuates about 1 degree throughout the day. For most people in the evening, body temperature reaches its peak. It rises to around 99.0 degrees Fahrenheit. At night, body temperature gradually declines. Around dawn, it reaches its lowest point. This temperature drop promotes deep sleep. When body temperature falls, brain metabolic activity decreases and sleep deepens. Conversely, rising body temperature promotes wakefulness. In the morning, as body temperature begins to rise, you naturally wake up. The timing of peaks and lows varies by individual chronotype and measurement site. You can adjust this temperature rhythm through exercise and diet. Your digestion and metabolism also follow circadian rhythms. Digestive enzymes secreted from the pancreas, amylase and lipase. These peak in secretion from morning to midday. Insulin sensitivity is also highest in the morning. Even with the same calorie intake, morning metabolism is more efficient. At night, these activities decline. Eating dinner late and in large amounts results in poor metabolic efficiency. This increases the risk of weight gain and metabolic disorders. This is the field called chrononutrition. It deals with the relationship between eating timing, circadian clocks, and metabolism, where late-night meals and irregular eating can negatively affect metabolic markers. In particular, more than what you eat. Limiting your eating window to within 10 hours becomes a powerful switch for regulating your body clock. Are you a morning person or a night person? This isn't just a habit. It's largely genetically determined. It's called chronotype, your individual sleep-wake preference. The length of the clock gene, period 3, influences this. People with the longer version tend to be morning types. Variations in the clock gene also play a role. Genetic influence is present to some degree, with research estimating moderate heritability. In other words, your chronotype is explained to some degree by your genes. The rest is environmental factors. You can adjust through light exposure, social schedules, and lifestyle habits. Completely changing from morning to night type is difficult. However, some degree of adjustment is possible. Jet lag and shift work. These disrupt circadian rhythms. Jet lag involves rapid time zone changes, requiring both the central SCN and peripheral clocks to resynchronize to the new time. Differences in resynchronization speed cause internal desynchrony. Shift work is chronic circadian rhythm disruption. The IARC under WHO classifies night shift work involving circadian rhythm disruption as Group 2A, probably carcinogenic. Multiple large-scale studies link night shift and rotating shift work to increased risk of cardiovascular disease and type 2 diabetes. Circadian rhythm disruption affects metabolism, immunity, and DNA repair, all of it. Nighttime light exposure suppresses melatonin secretion, reducing antioxidant effects. This contributes to increased health risks. To optimize circadian rhythms, there are 4 pillars. Step 1. Morning light exposure. Expose yourself to bright light as soon as possible after waking. Outdoor natural light or bright light is needed for 20 to 30 minutes. Optimal conditions vary by individual. This resets the SCN and suppresses melatonin secretion. It regulates your rhythm. Step 2. Consistent sleep schedule. Go to bed and wake up at the same time, weekdays and weekends. Consistency is generally best, but recent research suggests that only in cases of sleep deprivation, moderate weekend catch-up sleep may lower heart disease risk. This is most important. The body clock prefers regularity. Step 3. Reduce light at night. 2 to 3 hours before bedtime, dim room lighting, and avoid strong screen light. When you combine strong morning light with evening dimming, the body clock adjusts more easily. Step 4. Chrononutrition. Prioritize breakfast and keep dinner light. In particular, limit your eating window to within 10 hours. This optimizes metabolism. Now, let's organize today's key points. Here's today's summary. First, bright light exposure in the morning resets circadian rhythms. By exposing yourself to bright light as soon as possible after waking, the SCN resets precisely to 24 hours, melatonin secretion is suppressed, and your rhythm aligns. Second, a consistent sleep schedule is most important. By going to bed and waking up at the same time on weekdays and weekends, your body clock stabilizes and long-term health risks are reduced. Only in cases of sleep deprivation, moderate weekend catch-up sleep is also effective. Third, reduce light at night and restrict your eating window. By dimming lights 2 to 3 hours before bedtime and limiting your eating window to within 10 hours, metabolic efficiency improves and health risks are reduced. Will you live with awareness of circadian rhythms starting today? Why not start by exposing yourself to morning light? Share your strategy in the comments. Thanks for investing in your health today. This channel explains how the human body works and health optimization based on scientific evidence. Evidence, not emotion. Science, not trends. Illuminating your path to health. Subscribe to the channel, and let's learn the truth about the body together next time. Turn on notifications, and with each new video, your health knowledge will level up. See you next time.